Today let us talk about electromagnetism. It is a unified force. Electric and magnetic fields are not separate entities, but they are two sides of the same coin. So we refer to it as electromagnetism. This presentation explores how stationary charges create electric fields, how moving charges create magnetic fields, and how their dynamic property is being summarized by Maxwell's equations. So, electric field originates from stationary electric charge and they exert a force on other charges in their vicinity. Okay? So, protons and electrons constitute the electric field. Their interaction is like charges repel, opposite charges attract. And the lines of force always point away from the positive and it is towards the negative charge. You have some laws governing these, that is Coulomb's law. It describes electrostatic force between the 2 point charges. This is fundamental building block. Force is directly proportional to the product of the charges Q1 and Q2 if you say, and if the distance separating them is r, it is inversely proportional to the square of the distance between them. This is the mathematical formula. This is a force exerted by the plus Q charge onto this. The reverse force is in this direction. We already have studied gravity and what is the difference. Newton's law is of universal gravitation. They differ in scale and nature. Both are the universal laws. The nature of the force is gravity is only attractive because everything is always attracted towards gravitational force. Everything is attracted towards the earth as a gravitational pull. Whereas electrostatic force can be attractive as well as repulsive. Because opposite charges attract each other, that's attractive force. Like charges repel, therefore it is a repulsive force. When it comes to the strength, the electrostatic constant is roughly larger than the gravitational constant, very much larger. So at the atomic scale, gravity is negligible. Okay, the strength is very high. Then it comes to medium. Gravity is unaffected by the medium between the masses because very far off objects also are attracted towards gravitational force, whereas electrostatic force is significantly weakened by some materials like dielectrics, paper, wood and so on. They are insulating materials, so it is affected. Then let's talk about electric field lines. They're intuitive. They're proposed by Sir Michael Faraday. The lines indicate the influence of a charge in space. What does it mean? It shows exactly a small positive discharge would move if released at any point. So, how the charge moves is described by the electric field lines. The rule is you have a hypothetical positive charge. A positive charge is pushed away from the other positive charges, so it's moving away. And it is drawn closer towards the negative charge. So they terminate, field lines terminate at the negative charge and they are produced from the positive charge. So positive charge is treated as a source, the negative charge is treated as a sink. Source and sink are source and drain. Then you have a density rule. It states the magnitude of the electric field at any point. It is directly proportional to the number of lines. More the number of lines are, more the density. Lesser it is, the lesser density. Number of field lines per unit area perpendicular to the field direction. Okay, if they are bunched together, the field force is intense. If they are spaced, then it is weak. And another rule is they never cross each other. Because when they cross, what happens is single point in space can have only one unique net force acting upon. If they cross, it will have two lines of force, which is again the violation. What actually is happening at the intersection when there are two lines intersect each other, the two curves, you can draw multiple tangents, which is not possible, which is against the laws of mathematics. Also, it will have two directions, that is conflicting. So, if you place a test charge at that spot, it will be pulled in two different directions. So, you cannot have multiple tangents, you cannot have conflicting directions, and being pulled in two different directions. All these three are violations. So, the conclusion is the net electric field at any point is the vector sum of all nearby influences, and there is only one resultant vector. Force is a vector, and there is only one possible field line passing through that point. This is an inverse square law through line density. The same unit of flux must pass through a small area near the source and a much larger area for the array. The magnetic fields are created by the tiny magnets, spin of particles. They always exist as dipoles. In the case of electric fields, it is electric charges. They exist as single charge, but in magnetism, they exist as dipoles. You can't have a north without a south. So, moving electrons are the source for the electric field. Permanent magnets are for the magnetic field. They exert forces only on moving charges. Okay? And they form continuous closed loops from north to south. Intersection you have already seen. So this is being repeated again.